bisector. Okay? It is exactly like it sounds. I am going to draw a triangle, and when I draw my triangle, I'm going to make it an isosceles triangle. Okay? So draw a triangle that looks like it's isosceles. Okay? The perpendicular bisector is this red line. Okay? It is perpendicular to the base, and it bisects the base. That's why it's called a perpendicular bisector. That's an appropriate name, right?
What's the one with that last chapter?
Lines? We didn't learn.
On the bisector.
Angle bisector, segment bisector? Okay. So essentially the perpendicular bisector is a segment bisector because it's cutting this segment in half. Okay? But the reason we call it a perpendicular bisector is because not only does it cut it in half, it's perpendicular. So for example, okay, I could have this line cut in half, and the blue line is a segment bisector because it cuts it in half, but is it perpendicular? No. Okay? So that's the difference between a segment bisector versus a perpendicular bisector. Okay? Sound good? Okay? The picture. Okay? All right, next. Equidistant. Use your root words and your prefixes and tell me what equidistant means. All right, so equidistant simply means equal distances. Whoa, we blew her mind. Okay, all right, so I am going to go back to the picture when I talk about the theorem. And the theorem basically says that any point on the perpendicular bisector, I will abbreviate perpendicular with the upside down T, okay, is equidistant. That's a funny word, huh? Okay. From the end points of the segment. So any point on the perpendicular bisector is equidistant from the endpoints of that segment. Okay? And I'll explain what that means. All right, in the triangle, I'm going to label A, B, C, D. All right, so BD is referred to as the perpendicular bisector because it's the one that is perpendicular and it is cutting AC in half. Okay? Now, if D is on the perpendicular bisector, would you agree that D is the same distance away from A as it is from C?
Yes.
So we would say that D is equidistant, has the same distance away from A as it is from C.
Correct.
All right, so there you go. That's what it's saying, okay? Now, it is also saying any point. So, is point B on the perpendicular bisector?
Yes.
So what is it telling us?
It's equal distance.
So explain in terms of like maybe a congruency statement or something being equal.
is congruent to BA.
Do you agree with that?
I would say, yeah, BC is congruent to BA.
So would you agree that B is the same distance away from A as B is from C? Because it's on the perpendicular bisector. All right. So now I am going to take away those tick marks that I just drew for a reason. Okay, to explain why the theorem works. And we got to go back to chapter 4. Can anybody give me a reason why this triangle on the left is congruent to this triangle on the right?
Reflexive property.
All right, we do have reflexive, okay? All right, wait, that's great. I love it. I'm glad she's excited. That's great. All right, so we do have the reflexive property, but why are the triangles congruent?
Because A, B, D is congruent to C.
No, I'm looking for...
Great. Side and side.
Okay, so we're going with
S.
the reason I went to you was SAS. SAS. Okay. All right. So.
Just imagine you two right now. What are they doing? What's wrong with that?
All right. So the triangles are congruent by SAS. Why is AB congruent to BC now?
4K,
CPTC.
Because of CPCTC. Okay? All right? That makes these now congruent to each other. Okay? Now, the reason why we have the perpendicular bisector theorem is so that you don't have to go all the way through and prove the triangle is congruent and then say the parts are congruent. Okay? With the theorem, we can now just say that they're the same distance away. Okay? All right, so now our goal is to apply it. Okay? And we like to do that with algebra. So in the figure below, BD is the perpendicular bisector, which means it is perpendicular to AC and it cuts it in half. Okay? All right, find the value of AD. So based upon the theorem that we just talked about, how can we apply it?
3x plus 14 equals.
And says 5x equals 3x plus 14. Is that where you were going to get to?
3x.
Same thing, okay? All right, solve for x. Tell me what you get. I heard 7.
it is 7, I agree.
Right.
Did we answer the question?
No.
Okay?
So, do you want me to answer?
35.
I got a 35 over here. 35?
That's
35?
That's an accurate.
5 times 7?
Is accurate.
21 plus 14. Okay, so AD equals 35.
Yes.
Okay? So the reason this works is based upon the perpendicular bisector theorem. D is on it, which tells us that these two are equal to each other. Okay, so that's the idea. Okay? All right, so now, if HI is the perpendicular bisector, using the concept of the equidistant, okay, which distances, segments, or lengths are equal to each other or congruent? Karina? HI is congruent to? No. What segments are congruent to each other? Maddie?
E, F, and G, F.
Well, we're going to save that for later. Go ahead, because the F hasn't passed it through it yet.
EH is congruent to HG.
All right, so EH is congruent to GH. Do you agree, since G is on the perpendicular bisector, that EH is congruent to HG?
Yeah.
Okay? Give me another set of segments. David? EI is congruent to GI. All right. So now, the second part of this is we're supposed to determine whether or not F is on HI. HI doesn't pass through it. So just so you understand the concept of the question, it's saying that if this is HI, the one that's going up and down, is F over here, or is F actually going to get passed through by the line?
Yeah.
Okay? How do you know? Don't go based upon, oh, well, it looks like it.
You can just draw a straight line up and it
Correct.
goes right through.
And what if I draw it straight up and it misses it by just a tiny little bit?
Well, then you need to rule it.
Okay.
Is it because the side length,
It's 25 and 25.
G are the same?
Okay, well,
Correct.
obviously does.
Because these are equal to each other, then we know that F has to be on the perpendicular bisector because they're equidistant, okay? So think about it this way. If I go back to this picture, okay, and here's my E and here's my G, okay? Would you consider EG congruent to FG in this picture? No. But if F was on the perpendicular bisector, would you now consider them equal?
Yeah.
Yeah. So that's the difference, is if it's on the perpendicular bisector, these are equal. If it's not on the perpendicular bisector, these are not equal.
What happens if it's not on there?
Then they're not equal to each other. Okay? Does that make sense? Okay? Good? All right. So our answer for today is yes, because 25 equals 25. If it was 24 and 25, we'd say no. Okay? All right. And example number 3. Find the length of AB.
And then, which means AB equals 24. You said no.
Oh, wait. He's got x equal to 6 and AB equal to 24. Sam, do you agree?
I got x equals 6, then
What is
x
26?
plus a is equal to
It is
26.
26, I can't add.
So you want to go 26.
It is 26.
All right. Somebody else to verify?
I got 6.
All right. So it should be 26. Okay? All right. So that's the concept with the equidistant. Basically, if you look back at this triangle, again, the two triangles are congruent by side angle side. Therefore, the parts are congruent by CP, CTC. Okay? All right. So over here, you have to determine whether or not C is on the perpendicular bisector. Okay? So since you don't know, you can't draw in. You can draw the line, but you cannot draw the perpendiculars, and you cannot draw the tick marks at the bottom, because you cannot come up with a reason for that, because it's asking, is it? Well, we don't know. So if I draw in this red line, do I have enough information to prove the left triangle congruent to the right triangle?
Yes.
Tell me why.
Well, because AC and CB are congruent.
So in a triangle, you only need to show one thing congruent to prove the triangles are congruent. I thought in the last chapter we always had to show 3.
It does have to be 3.
Okay?
Yeah, so you don't
So
have
can we
that.
come up with 3 congruencies?
Negative.
You sure can.
Okay, give me 3.
No, because you
Oh, no, there's not enough
because then
information.
you're
Yeah.
assuming.
Okay, you got reflexive. Can we come up with another one?
No.
The right angle, but that's assuming, right?
Because remember, you have to be able to back it up with a reason, and I said you're not allowed to draw in the perpendiculars and you're not allowed to draw in the bisector part. Why is angle A congruent to angle B? Okay, I'll go with that. Okay? All right, so we do have 3 things. Is that still enough information to prove the triangle congruent to each other? Why? Because what is this? It's ass. There's no ass. No ass in geometry. So therefore, not enough information, so we say no. Okay? So you have to be able to come up with enough information to show the triangles are congruent. Okay? All right? What about this one?
No.
Don't assume.
Okay, I'm not assuming, that's why I'm asking. So, what do we say? You say no?
I say no.
Anybody want to say yes?
I'll say yes.
You want to say yes? All right, give me a reason.
Well. You know what? I changed my answer. No.
Okay? So what if I threw out that this angle is congruent to this angle because of isosceles triangles again?
Well, if you were to put that there.
Wait, no.
But I can come up with a reason because of isosceles triangles, right? Base angles are congruent if the sides are congruent, right?
There's 2.
Can I come up with this angle congruent to this angle?
Yes.
Yes.
Okay? Would you agree that the angles in the top triangle are congruent to the angles in the bottom triangle?
Yes.
Yeah.
Because the sides are the same, the angles are going to be the same? Okay. So do we have enough information to say the 2 triangles are congruent?
No. Yes.
All right, if so, tell me why. Zoe's saying A, S. Is that good?
There's no ASA.
It's not ASA. Okay? AAS, you agree with her?
Yeah.
Okay? So therefore, it is yes.
That's what I was saying is
Okay? All right?
the way you pronounce it is like
Okay? All right, so concepts so far that you need to understand is the parts are congruent if the triangles are congruent. We kind of learned that in the last chapter. And then understand that in order for you to determine it's a perpendicular bisector, triangles have to be congruent. So like I said, everything from chapter 4 is coming back, okay? All right, so concurrent. Just because we're going to use the word concurrency, point of concurrency, anybody know what concurrent means? To agree?
The circle is congruent
At the moment.
Set, I don't know.
What's C-O-N? Con?
Together with.
Together? All right.
Is that,
All right, so concurrent means they're going to come together or at the same time. So we'll say, or we're going to interpret in terms of geometry, we're just going to basically say concurrent is where they're going to intersect. So our point of concurrency is going to be the intersection, in our case, of 3 lines. And those 3 lines are going to be 3 perpendicular bisectors. Tomorrow it is going to be 3 angle bisectors. Monday it's going to be 3 medians and 3 altitudes. Okay? All right. The point of concurrency has a particular name. So one of the goals that you are going to have to do is put the correct lines with the correct point of concurrency. There are 4 of them. Circumcenter, incenter, centroid, orthocenter. Okay? For today, the point of concurrency for the 3 perpendicular bisectors is called the circumcenter, because when we have our circumcenter, which is in this case O, and draw our circle, the circle goes around the triangle. Okay? Think about circumnavigates the globe, goes around the globe. Okay? All right? So that's what you have to understand. You have to be able to put perpendicular bisectors and circumcenter together. Okay? Is that hard? Is that hard to do? As of right now, we've only done 1 out of 4. You seem okay. All right. Okay. Whew. All right.
Did it record me saying S as well?
Yes.
Oh god. And I said that so proud too.
But nobody knows who's talking, so it won't matter. Okay. All right. So next. Okay. In this picture, you need to understand, and it says it in the direction, O is the circumcenter. If you need to label it better, go ahead and do that. Okay. Notice that this line here, okay, is perpendicular, and it cuts the side length in half. So that purple line is the perpendicular bisector. Okay. On AB, this other purple line is the perpendicular bisector. Notice it is perpendicular to AB and cuts AB in half. And then this little one over here is also a perpendicular bisector. It is perpendicular to BC and it cuts BC in half. So there are 3 perpendicular bisectors and they are coming together or intersecting at O. That's called the circumcenter. Okay? All right. Big piece of information. Okay, when we talk about properties of a perpendicular bisector. AO, BO, and CO. What would you say is true about those 3 lines? I heard congruent.
The 90 degrees.
Nope.
Current.
Well, that is true because they're coming out of the, circumcenter. But I heard congruent. Okay? Congruent is correct, but can anybody come up with a reason why they're congruent?
Oh, I know. They all, like, they all have, since they're split in half, each triangle is congruent to each other, like, you can put it that way.
Okay?
Yeah, that can be more than that.
Oh.
Am I able to say siding the side?
No?
That's what I was gonna say, I give up.
Anybody else? All right. Here's what I want you to compare. The 3 green lines with the circle and tell me what they are called in relationship to the circle.
Star.
I'll give you a hint. Begins with an R.
Radius.
Radius. What's true about every radius of the circle?
Half the diameter.
They're half the diameter and they are
Pi r squared.
equal to each other. Okay?
Yeah, isn't that how you find the radius?
That's the area of the triangle or the circle. Okay? So, think about spokes on a bicycle. All the radii are equal to each other. So, in the picture, big piece of information that you need to be aware of is that AO is equal to BO, which is equal to CO. Okay? The three lines. And those lines are coming from the vertex of the triangle to the circumcenter. Vertex of the triangle to the circumcenter. Vertex of the triangle to the circumcenter. Okay? Questions there? Yeah.
What do we fill in for called?
You could put in circumcenter. I just underlined it instead of filling it in. Okay? All right? All right. One more piece of information before we go to the next page. Okay?
Okay.
Okay. All right. So in this picture that you see here, okay, can anybody give me a description for each of these 6 triangles using a word from the last chapter that we learned?
We'll start
SAF.
Describe the triangles. These are on. You're on the right track. They're all right triangles because notice that they all have right angles. Okay? All right. So, there is a tiny little assumption that they are going to think you know. So, in this triangle, right here, I'll just pull out one of them. If they were to give you 2 side lengths of the triangle, like say 13 and 5, they believe that you know how to find the 3rd side.
Well, they're wrong, because you can't.
But you can't. Does anybody remember how to find the 3rd side length in a right triangle?
Isn't the height and base the same, right?
It could be, but not in this case. Has anybody heard of a squared plus b squared equals c squared? What is that called? The Pythagorean theorem. Okay? So did you do this last year in 70-71? Yes. Okay? All right. So now, big concept in terms of using the Pythagorean theorem. You need to know which of the 3 sides represents the C because it's the one by itself. Which one is the C?
The bottom.
I heard the bottom. The blank one. Anybody else?
Oh.
How about C is always the one? Not the one not shown. It's the hypotenuse. Which one's the hypotenuse?
That's the long one.
The long one, but they didn't give us all 3 sides, so you don't know which one's the long one. All right. It's the one opposite the right angle.
Yeah.
It's always the slanted one. Okay. So in this case, it doesn't matter which one 5 represents, A or B. It'd be 5 squared plus B squared equals 13 squared. Okay?
Why is 5 squared 8? We got it in 1 minute.
It's a good thing that we can do these last 2 questions in 1 minute. Can anybody tell me what US equals?
USA.
US equals US equals UW.
US.
I don't get why it's 14.
What's GA equal to?
GA is equal to
Biggest
13.
fail.
Okay?
Wait, why not?